Hey guys, my name is Sameera, and today I'll be talking about my FEA project, which is a two-phase static analysis of a 3D tire. So for the background and inspiration that went behind this project, it basically came from my personal experience with my own car, just working on it whenever I find the time. So it's based on my silver 2010 Toyota Camry. It weighs about 3,461 pounds. It has size 16 tires and basically the static analysis, it's broken into two phases where the first phase involves inflating the tire to 35 psi as recommended by the user's manual. And the second phase involves installing that tire onto a wheel and placing that assembly on the road, and then applying 1/4 of the vehicle's total weight on the wheel as a body force. And so what I'll do here, I'll stop sharing my screen so that I can instead share my Abacus window. Just for the sake of time, just because I have broken this into two different phases, I'm not gonna go through the tutorial from scratch. I'm just gonna like kind of show you guys the rundown for each module basically. So basically what I did for this phase one of the project, I started by creating a part. And this part is my tire. I made it a 3D deformable shell revolution part. And so what I did, I created a section sketch that has a 2 unit diameter or 2 inch diameter radius, 10 inches from the origin to the right. And then after that, I added a datum point right in the middle. So the next step, I went to materials or the property module, and I went to the materials manager. Ignore materials 2 and 3 for now. That's going to be for phase two. The only thing for phase one I did is I added material rubber with 435 psi for the Young's modulus and then zero point 0.5 for the new value. Um, then I created a shell homogeneous section with a shell thickness of 0.1. Everything else I kept the same. Then I assigned the section to this part. Um, so then I went to the assembly, placed the tire in the assembly. Uh, so that one was pretty straightforward. And then I created the new step, and this is just a static general step. I kept all the settings like I left them default. Um, there's no interactions for this one. For load, the only load I placed was me inflating the tire with 35 psi. So that's you place that as a pressure and you just simply click the tire and it'll ask you which surface you want to do. Like, do you want to do the outside surface or the inside? And they show you designated by color, so you can choose the inside surface by doing that. The only boundary condition I placed was in caster on this bottom node here, like the contact node where the tire's resting in space, basically. Just so like when we air up the tire, it doesn't like roll away while you're filling it up with air or anything like that. Um, so then after, oh, I forgot to show you mesh. Hold on. So let's go to mesh. That's the only thing, right? Yeah. Okay. So we go to mesh real quick. Um, what I did here, I specified, okay, so I have shell elements. They're called S4. I turned off reduced integration. And then for mesh controls, I left it quad dominated and free. And then I seeded this with like 14 elements or something. Yeah. Seeded the edges with 14 elements, and then I ran it, and it has, if we check the nodes on this, it shows 980 down here. So we're just under 1,000. So we're like we're using almost all the nodes we can. Okay, so now that I've already submitted the job, I didn't change anything. I was just showing you. We can view the results. So here's the undeformed tire before inflating it, and then here it is after. And interestingly enough, I went back to like the spec sheets for the size 16 tire, and these dimensions of like the inflated shape, they agree pretty well with the values of, like the dimensions of the tire in real life. So I thought that was pretty cool. And then I verified von Mises, hoop stresses, and longitudinal stresses with hand calculations as well. And so that's the end of phase one. I mean, I can show you real quick, just like the U plot, the magnitude plot. Okay, so that's the end of phase one. So phase two is where I added the other parts. Um, let me open my file for phase two real quick. Let's see. So this has like everything in it where I basically have same tire from before. We added a road and we partitioned it. And then we added a tire. I mean, we added a wheel and we partitioned it as well. And then we added a mass, uh, a point mass to the middle as well. And then we created the new materials. This one is, I believe, concrete. This one. Yep. And then this one is the alloy, which is used for the wheel. And so we have again, the modulus of elasticity is in PSI. And then, so then after that, we created, so just as a heads up for so the section is the same, solid homogeneous for both the road and the wheel. So you'll notice it's like the road and the wheel are kind of simple almost because they're just solid extrusions with solid homogeneous, and it's just because of they're fairly rigid parts. That's the only reason why I went simple just for those parts. They're fairly rigid parts and they have uniform geometry, so I just partitioned them into like 4 quadrants basically. So then after that, I went back to the assembly. I edited it as needed. So then it ends up looking like this. So the tire is touching the road and the wheel. I added some interactions. Surface to surface contact is what they're called, between the wheel and the tire, and then between the road and the tire. Same story for constraints, except I used tie constraints. And then for the loads, the only other load I added was the 1/4 of the weight of the vehicle, which in this case is negative 865 pounds, and it's acting on the wheel as a body force. Boundary conditions, the only ones I have are just like fixed on the bottom of the road, and then the wheel is fixed because we don't want that wheel to move either. And then after, oh yeah, and for mesh, uh, for the road, you have hex elements with structured mesh controls, and then for the wheel, you have wedge mesh controls, and then triangular wedge element type as well. And so I, after, after seeding and mesh refinement, I got my assembly to have a total of 966 nodes, which I think is pretty almost fully maximized. So then now we can submit the job and then we can view it. And then the results for that are going to be here. And so here, not deformed, here's deformed. And you can see the contact patch. If I were to hide this road. So here's the magnitude plot. Here's the rotation, displacement, or so what I'll do, I wonder if I can hide. I wonder if I can hide the road. But basically, I can't figure out how to do it right now for some reason, but what you can do is you can hide this road and you can see the contact patch and you can almost see like the faint shape of an ellipse, which is something you would expect in real life, which I thought was pretty cool. So that's pretty much it for the project. There's my tutorial as well. If you have any questions, feel free to reach out. But other than that, thank you so much, and I hope you have a good day.